Hello and welcome back. It's puzzle time with Sudoku Sleuth, and today we're going to be playing 12 spots. I'm actually just quickly curious, do I have 12 spots in the constellation there that's behind Sleuth in the sky? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So essentially, if you don't count the tail, yes, there is 12 spots. Now, this is all highly relevant once I actually bring up the grid and today's puzzle, 12 spots from Marty Sears, where essentially we do have, we'll call it 12 stars, and we're connecting them with almost lines of constellations. It's a yet another variant. I've done quite a few new variants this weekend. I don't know why, but I think it has to do with the fact that this is a 98% rated puzzle as of the time of recording. So really looking forward to this particular puzzle. It's clearly going to be a lot of fun if we can figure out what the rule sets all mean. Speaking of which, let's take a look at today's puzzle and rule sets with 12 spots in Marty Spears. And you can see the stars here that I was referring to. And the following set of rules. Normal 6x6 Sudoku rules apply. That means place the digits 1 to 6 once each in every row, every column, and every 2x3 box. Now, we need to draw 6 lines each with a different turquoise spot at both ends. Each line must occupy at least 3 cells and may move orthogonally and diagonally. Lines may not branch, cross each other, or share cells. So that's a lot of words to say what I think is something roughly as follows. So every pair of spots is essentially connected by a line, something like that. The lines themselves have to be at least 3 cells long, so I'm counting the stars plus any adjoining cells. The lines can obviously go in any direction, as in they can go orthogonally or diagonally, as I've done here. What they cannot do is essentially cross. That's not allowed. And what they can also not do is branch. That isn't allowed. So we're looking essentially almost like at a clean constellation, so to speak. Now, each line is a same difference line. So every pair of adjacent cells along a line has the same difference. This is its difference value. So let's see if we can come up with an example here. If this is 1 and this is 3, there is a difference of 2 between these pairs. The next pair must also have a difference of 2. That could be 1, that could be 5. All of that works. Every line has a difference value. So once essentially I've used a difference of 2, let's just come up with another line here. I don't know, something like, I don't even know if that's allowed. I can't have a difference of 2 anymore. I've used it already on another line. Then, last but not least, digits in a cage sum to the total in the corner. So if that cell is a 2, this is a 6. To make sure these 2 cells are 8, these 2 cells are 11, these 3 cells are 6. Fascinating puzzle. Hopefully, I know what I'm doing. As always, link in the description down below for you to enjoy. And with that said, I'm going to restart the clock and see how I get on. So, I mean, the obvious thing is that this 6 cage is 1, 2, 3. The other obvious thing is that this cell here, this star, can't be connected to any of these. If that is the case, that is a 2-cell line, not a 3-cell line. So it absolutely has to go this way. Now, potentially, I can do something like 1, 2, 3 and have a difference of 2 with a 2 in the middle. Sorry, difference of 1 with a 2 in the middle. That would work. The only thing that I know for sure is it's kind of going horizontally this way. I'm probably going to end up doing something like this. I know that all of these are not lines, otherwise they will end up crossing, and that is, or branching, and that is not allowed. What is also not allowed is to do something like that, or that. So this one has to go horizontally. I don't know if it's is orthogonally up. It could obviously go diagonally. That's fine as well. And clearly not here either. Yeah, these X's are not actually that helpful because I don't know if they're going diagonally or not. Interesting. So an 8 cage in a 6 by 6 Sudoku means it can't be 1 7 because 7 is not an available digit, but I could do 2 6, I could do 3 5. I really don't feel like we have, oh, hang on, 11, this is 5 6. Obvious. And these two cells are not connected, otherwise that's only 2. So this cell is clearly branching out somehow. And these are 1 2 3 4. That's like not much of a deduction here. Right. What else we were given? We were given every line has a different difference value. So this is kind of quite interesting because we've got 6 lines. So one line, I don't know, let's call it blue. If I can actually, is blue, would be a difference of 1. Then there'll be a difference of 2. You can see I'm kind of running out of digits. 3, 4, 5, and I can't do a difference of 6. So I'm going to need like a difference of 0. Yes, that makes sense. So essentially, 1 will be 1. So I mean, it just happened to be that I picked these colors. So 1, 2, 3, 4, 5, and then 0. Because I can have a difference of 0. I could have two numbers that are the same, and then the difference is 0. What I can't have is a difference of 6, because 6 and 1, which is the two maximum and minimum digits, is a difference of 5. Interesting. Right. What does that mean? I'll tell you what it means. I need, let's assume that, hang on, that's not what I meant. Let's assume I need, it is very specifically, I think I've got it. It's got to be a line that looks something as follows. The challenge, of course, is how do I get 3 cells that are identical in this grid? And I think this is entirely forced. Essentially, it's something that looks like this, because I need to cross 3 different boxes in 3 different columns in 3 different rows. So this line is possible. This line is possible. No, this line is not possible. Right, let's think about which lines are possible. That is possible. That is not possible. So I'm going to just draw all the lines that are possible for a second. Come on, I keep selecting the wrong one. So that is possible. That is possible. These are not, because you'd end up with 2 in the same box. That is also not. So essentially, like the way I'm thinking about it is it always has to be kind of the one at the back doing something like that. Yes. And this one could obviously go 1, 2, 3, or so there is potentially something that looks like, come on, I'm trying to draw here. That wouldn't work. And then again, 1, 2, 3, and then 1, 2, 3. So one of these lines is the 0 line, the 0 difference line. I really wanted to do this in purple. I'm not going to change it at this point. Now, I know that it doesn't include these cells because that would be branching the blue line. So I'm going to discount these immediately. And essentially now, I am looking for either this line, this line, this line, this line, this line, or this line, all having the same digits. Which I'll be honest, is not very much to go on. Okay. But hang on, I'm not thinking straight. I need these lines to be connecting dots. Which one of these lines is connecting two dots? And I can only think it's this one. This clearly isn't. These three lines aren't. These aren't. And obviously it's a minimum of 3. I mean, at the moment, this one is the only one that seems to work. So I think this is correct. It has to be this line. And I am going to change it now to purple. This is the 0 line, which means all of these cells are identical. And I know what the digit is. And how do I know that? Well, it's not 5, 6. That part is obvious. But if you just imagine for a second, this is 1, 2, and 3. Well, this line sees all of them. It sees the 1, sees the 2, sees the 3, and the 5, and the 6. So, long story short, this is 4. Wow, which gives me another 4 in here, which gives me another 4 in there, and we're suddenly done with 4s. That is incredible. So we're suddenly done with 4s. So the zero difference line is very restricted, as we've just demonstrated. Now, the other one that would be quite restricted, would be the 5 difference line, because essentially it can only be 6, 1, 6 or 1, 6, 1. It's got to be oscillating between these extreme digits. Right. And it's got to be at least 3 cells. And clearly the first and third cell are the same. And if it's not, and if it's longer than 3 cells, as is the case here, potentially I'm repeating more. So again, we're kind of back to, we need to cross diagonally, otherwise we're going to have issues with Sudoku. This diagonal is actually quite important. I mean, I can do something like 6, 1, 6. That would work. I mean, let's talk about this, actually. Like, I don't know why I haven't thought about this earlier. Now, let's pick red or orange for this one. Clearly can't be here, clearly can't do that, 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 can't do that. What's the only path that is allowed without breaking the rules? Is only going up diagonally. Let's think about these cells now. These are 1, 2, 3. See, I'm now looking at this particular star, and I'm just thinking, I'm struggling to see how I can connect it to anything other than, something in the same row or something in the same column. Which kind of almost implies that this is the difference of 1. But with the 4 in here, that doesn't work, does it? Because 1, 2, 3, 4, 6, 5, 4, 3. So I can't connect this way or that way. 1, 2, 3, yeah. So I'm going to have to do something as such. I need to connect it. But even if it's if it's a difference of 1, I can obviously go back on myself, so to speak. So I can do 1, 2, 3, no. 1, 2, 3, no. 1, 2, 3. Also no. 1, 2, 3, 1. That doesn't work. 6, 5. 6. But what am I doing about this cell? Come on, sleuth. What are we doing? This cell is a real struggle now. So much of a struggle, I'm actually wondering if I broke it. But potentially, I'm actually connecting it to here, to this orange. And if I go with a difference of 5, I can do 6, 1, 6, 1, or 1, 6, 1, 6, 1. And that would work. See, in general, I'm kind of leaning towards this orange line being the 5 cell one, the 5 difference. Sorry I'm taking so long. It's just, this is a much harder puzzle than I'm expecting, actually. Right. I'm absolutely convinced I can't connect these two. Like in any order. Can't do something like that. Can't do that. I think I'm always going to struggle with the fact that, well, unless it's also, yeah, because if it's 4 cells long and it's a difference of more than 1, then I need to repeat a digit. Essentially, if it's a difference of 2, 1, 3, and 5, or 2, 4, and 6 is the maximum number of unique digits I can have, 3 unique digits. So the second that I am in the same row or the same column, I'm going to struggle with anything beyond just 1. Okay. And obviously because I have the 4s already placed, I don't think this could be connected in any direction. So long story short, I think if I connect it to this, regardless of the shape I take, let's try this. 1, 2, no. 1, 2, no. 2, yeah, because I've also got a 2, 3 in here. So like I just can't connect them to this. I'm convinced of this now. 1, 2, but you see 1, and then the challenge is, okay, how about if I start down the middle? 3, 2, 3. The 4 is just throws everything off. 2, 3, 2, 1. I can connect this one. Difference of 1, difference of 1, difference of 1. Yeah. Not helpful. Okay, 5, 6. Another 1, 2, 3. 1, 2, 3s again. There's a 5, 6, probably X-wing in here, or potentially they're both on the same row. How is this helping me? This cell is not here. This cell, they're all different. One of these is 5, 6. I think I'm going to have to go back to the 5 difference, because it is forced to be 1, 6. There's nothing else that would do. And because it's 3 cells long, I have to repeat those digits. So the 5 cage, the 5 difference line can never be these, because you end up, I mean, this is in general just a bad line, because you end up coming back to the same digit to get the same difference. But technically, I can do something like that. 6, 1, 6, 1. So I don't think I'm forced to make this the 5 difference. This is a way harder puzzle than I was expecting. Like, way harder. So, maybe we need to analyze the 6 gauge a bit more. Because it's either a difference of 1 or it's a difference of 2. Now, if it's a difference of 1, something that looks as follows is absolutely legitimate and it finishes the line. The implications of that is this is now 3, 5. And these two cells now are 1, 6. Kind of leads me to think this is the 6, 1. Sorry, the difference of 5, 1. That would be 6, that would be 1, that would be 3, that would be 1. That wouldn't work. See, 6, 1, 3, 1, and this can't be 1 anymore. Pardon me, I'm just analyzing what's going on here. Sorry, my neighbor's car has been on an alarm for like the past however long I've been recording, at least 18 minutes of this solve. And it is very distracting and frustrating. Right, maybe the other thing I should be thinking about is which cells connect. Maybe that's the way I should be thinking about it. So I think we've established this is purple. We've established that this is blue, this is orange. And then let's just try and find the pairs. For the sake of argument, this is red. Now, realistically, can this be connected to anything other than this cell? Let's give it a go. Come on. Something like that. Is that possible? And then this one will be connected as such. Yeah, like, I mean, I don't see why this is a problem. And this is here, and this is there. This is there. I'm starting to disagree, by the way, with the 2-star difficulty rating. I'm happy with the amount of progress I've made, but this is hard work. Maybe we should think about Sudoku for a second. What is this cell? Essentially, the rest of this, I have another 1, 2, 3, or a 5, 6. I need more lines to figure out which one it is. If this is 1, 2, 3, that would be very challenging because essentially it means this would be a difference of 1 or 2, same as this one. What about a difference of... So we've looked at 1 and 2, we've looked at a difference of 0, we've struggled with a difference of 5. I think we haven't really considered the differences of 3 and 4. And the thing is, in a 1x6 Sudoku, we kind of have the same challenge in that it oscillates. You see, 1 and 4 would go something like 3 and 4, 1, 5, and then back to 1. I can't go to 9. Same is true, 1, 4, and obviously it's not 4. It could be 2, 5, for example, and then it would have to be back to 2. Can't go to 8. So, in general, the 3 and the 4 lines. Remember those lines that I drew earlier for the 0 cage? I need more of these, in essence. But remember, it's not all the same digits, so it's not as restricted. But I genuinely need more of them. I need at least 2 of them. It's all the more reason to lead me to think this is, oh, hang on, not just 2 of them, because I need the difference of 5 with 1 and 6. The difference of 5 with 1 and 6, the difference of 4, and the difference of 3 all need to repeat the digits. So I need 3 diagonals that can only have 2 in the same box as a maximum. You can see how difficult this is now if I actually think about it that way. So essentially A, B, that would also work. So I could sort of loop around myself. I don't actually have to go as such. But I need 3 of them. And this is one of the 1 and 2. So this is one of the easy ones. Then I have another easy one. I say easy one. We kind of use the fact that this is actually quite difficult to do, like horizontally. So I don't think I'm missing Sudoku, am I? I mean, I'm not missing obvious Sudoku. How are we doing for time? 24 minutes. So what I'm going to do is I'm going to give this like 45 minutes. And if I don't solve it in 45 minutes, I may post it half done. Not sure. Anyway, we're getting way ahead of ourselves. So let's see if we can crack this. So the 0 line is done. Just going to remind myself the 3, 4, 5 lines I need to still do. This is not it. This is one of the 1, 2s. If this is the 1 or 2, technically I can actually still get up to 5. I can do 3 and 5 in here. Maybe I need to color a bit. I'm going to remove the purple. See if I can actually color it a little bit. Let's go with purple, blue, green. This is blue or green. This is blue or green. This is blue or green. Maybe for the sake of argument, let's make these the blue and green. I'm just going to pick at random which one these are. Which makes green in here. This can't be blue. We know that because we're done with the 0 lines. Yeah, it's just not helpful. It's just not helpful. I think we've got to figure out the 3, 4, 5 lines. They're the more interesting ones. It's just the fact that I could do weird things like that loop round isn't helpful. Really isn't. And the fact that this is 1 or 2 isn't helpful either. Right, so we've got one option, which is it terminates here. And it's a difference of 1. Of course, the other option is it doesn't terminate here, and it's a difference of 2. But I don't think it can ever terminate there. Can it? No, it could. I could do 1, 3, 1 if it's a difference of 2, and that would be 2. Then the 3 would give me 2, 6, and this would be 2. But then this would be 1 or 3. So that would be a difference of 1, that would be a difference of 2. That's fine. So I think that's the challenge, is I can always come up with a counter example to why the lines could go where they want to go next. So I can't connect these two because that isolates this cell. Does it? I can do something ridiculous like that. A, B, A, B, A, B. And I can even make it whatever I want. A, B, no. It would have to come back to A. So that would have to be one of the differences of 1 and 2 if I do something like that. And it isn't. This is one of the bigger differences. Yes. This, okay, here is a deduction, an actual reasonable deduction. Whatever I'm connecting to here, so if I go with a difference of 1, I'm in trouble because the next one along will be a difference that is clearly greater than 1. So this one has to cross kind of diagonally. And now that is clearly a difference of, well, it could be 2. I could do 5 and 3. Essentially, I was angling towards this is one of the 4, 5. Yeah, but it can't be. It has to be the difference of 1 or 2. Reason is, if this is a difference, no, if it's a come on, sleuth, think. We've established that this is green. Purple, blue, green. So let's try and make this line go anywhere other than connecting this cell. If I go in here, well, that's a challenge. Essentially, whatever the difference is between these two cells, I now need to repeat. So short answer is no, it can never be, regardless of what the difference is. It has to go into this cell. And now this is forced to be, no, it's not forced to be anything. Because I could do a difference of 2 with 5, 3, and then back to 5, because this would be 6, or 1 for that matter. Or I can do something silly like 6, 1, 6. But anyway, these lines are connected. And it's a difference of either 2, 3, 4, or 5. I mean, I could do whatever I want. Oh, hang on. They have to be the same now. Whatever the difference is, whether it's 2 or 6 or 5, it always goes back to the same digit. This is 5, 6. This is 1, 2, 3. Did I just make this way harder than it really is? I don't think I have. These are like hard-won deductions in my view. Okay. I'm not liking the fact that I still have an option of 2. I was really angling for one of the 3, 4, 5 options. Doesn't matter, I guess. So that's one more line. Nothing stops me from going back to purple in here. And therefore nothing stops me from just going straight as such. I'm going to use a different color. I'm going to use green for this one. So yeah, that works totally fine. I would just literally just, yeah. But if I do that, this would have to be a difference of 2. If it's a difference of 1, I would have a 2 in here. Oh, well, I mean, I could do 2, 1 and then 3, 5. So anyway, I don't know what this is. Right, these two have to be connected now? That can't be possible. How would I connect them? Anything that doesn't connect these two would isolate one of them. Yeah. Regardless of how I try and do this, they end up touching and sharing cells, and they're not allowed to. And if I come back to the cell, regardless of how I do it, this inevitably needs to be the same digit. A, B, A, B, A, B. Unless this 4 line was wrong all along. I don't think so. I think I'm on solid foundations with this one. And again, you can't go back into the same column. So what am I doing with these two? The fact that they're different parities is always a problem. And that I use the 4s. And the 4s are out of reach. I'm not getting this. 35 minutes. So we know you can never zigzag. We know that the zero line needs to do something that looks roughly as follows. And it can never zigzag. So it was always going to include two cells in the middle as such. And I always needed two cells in the middle that connected like two balls. And it always needed to gravitate around this center. Because doing it from the sides, you always end up with a problem in that you end up with two cells that are there. What happens here is that you cross different boxes. So, and I can't zigzag. I can never zigzag. So essentially I was always looking, so like that doesn't work because again, this one would be the same digit. That doesn't work. So it's not these dots, it's not that dot. It's not that dot, it's not that dot. It's not that one. Can't be this one, it's too short. Can't be that one, can't be that one. I think the zero line is forced. Then once it's forced, it places the 4s because of the 1, 2, 3 and the 5, 6. And it places the 4s. Then it ends up making this a 5, 6. Then we have the challenge of the fact that this is 1, 2, 3 and these are 5s and 6s. So if I end up with a difference of 1 and I'm not getting to 4, that doesn't work. So this has to be here. And then you can never zigzag. So you end up with this 5, 6. So far, I can't find any faults in this logic. The thing is, it's clearly broken, like clearly broken, because these two cells can't connect. So if I go with a difference of, because essentially I'm trying to get between odd and even, so the difference has to be an odd digit to stand the chance of actually flipping parities. So like I'm just going to try some digits at random, 6 and 5. And I have to have a difference of either 3 or 5. 1 is too close because 4 is not within reach. 5 is not within reach. But hang on, let's try if this is 6 and this is 5. I could do 5. No, that doesn't work. It's too close because I can never use the 4. I mean, these 4s are all occupied. It's only this 4 that is available, right? So let's just keep trying something until it sticks. Let's say it's a 3. So it's a difference of 3. And if it's a difference of 3, I'm in trouble because 3 is too big to do anything other than oscillate back to 6. Oscillation is not a problem. Oscillation is not a problem if the difference is 1 or 2. So this can't connect here because it breaks these two cells, but it will have to go here. And it has to be a difference of 2 now. And this has to be 5, and this has to be 3 because that's the only two digits that can satisfy that. And then I make this a 1. And this is a 2, and this is a 3, and this is a 1. And these are 2 3s. These are not 3s. This is a 1, 2. But obviously now that I've used a difference of 2, You can see now this is 1, 3, 5 in essence because I need to connect it to another dot. But anyway, 1, 2, 3, this now has to be a 2. This is the 1, this is the 3, that's a 2, because I've used the difference of 1 in essence. Sorry, the difference of 2, so this has to be a difference of 1 because it's a different line. Right, we're at 42 minutes. I think I've got this now. I think I finally understand it. Famous last words, but 5 gives me 6, gives me 5. These are now connected. And this, I need a difference of 2. Only the 3 is available. So this is the green one. And then I need either a 1 or a 5 to connect to it. That is not 1 or 5. Nothing around me is 1 or 5. I mean, I'm leaning towards this one, obviously. But I just realized that this could be the 5. So, well, hang on. If it is the 5, where is the dot? Because I can't jump back in here. Because if that's 5, that would have to be 1 or 3, and it clearly isn't. So if that's 5, that would be another 1, 3. Yeah. I'm fairly sure this is 5, but anyway. Right. This is not 2. This is not... Okay, hang on. 2 means this is 3, 5. These are now have to be 1 and 5. No, 6. This is a difference of 4. And 4 means it will stay on evens. It can't come back to this cell. These cells now are, whatever it is, 2 and 3. That's 3, that's 2. So a difference of 4 means I have to go to 2. And then I've broken it. I was so excited for a second. Because I need to get to a 6 again. And the only place I can place a 6 is in here. Which frankly is no good. So this is definitely a difference of 2, because otherwise it isolates these 2. Because I've used a difference of 2, that means that this is a difference of 1. Difference of 1, I couldn't do 3, 2, 1 because that was a 3. The 2 had to be in the... Well, it didn't have to be in the middle, to be fair. This part is correct. But technically I can end back in here. I don't have to continue. I mean, it still is a 3. I don't get away with the fact that this is a difference of 4, and I have to oscillate between 2 and 6. And the only place for a 6 now is one of these 2 cells. I mean, I'll draw it. But I mean, it's not helping me. And these are 1, 5. This is 1, 5, 6. I mean, it makes... Chances are this is 2 and this is 6. But what I really need is the 2 up here. So it can cross as such. So how did I end up with a 2 there? Why did I make this a 5? Is the answer. Yeah, that's the problem. Sorry. Rewind. I marked these as 5, 6 incorrectly. When I thought I had to connect it. Yes. So whilst this is indeed continuing as such, and it is indeed, yeah, there we go. Thank goodness. Right, this is indeed 3, this is 2, no, hang on. Yeah, this is 3 because I've got 1, 2, and 3. This is 3. Right, let's just... Right, but clear this up. This is not 1s. This is a 2, 3 pair. That makes this a 1. Fairly sure that's a 2 now. And that's the 6. So I can make this work. And difference of 2 makes this a difference of 1, which puts the 2 in the middle. Makes this a 5, 3 option. Makes these a 1, 6 option, and the 1 has to go here, and the 6 is there, and therefore there's a 2, that's a 1, right? Now, I need a difference of 4. Yeah, so it's oscillating between 2 and 6. This is a 3. Remember, this blue line could come back in here, so don't make an assumption again, sleuth. 3s, not in anywhere except here. 2, 5 pair. Let's learn from that mistake. This is definitely a 6 now. Therefore, this is 2, 5. Therefore, this is a 6. And this is 5, 6. I mean, we know that this is the 5 and this is a 2, so I can stand a chance of connecting, but let's figure out what all of these are for a second. Try and avoid more silly mistakes and assumptions. 1 is not here. 1 is one of 2 cells, and obviously if it's this cell, I break the purple line because I need it to be 2 or 6. I can't get to this one. Can I not? Yeah. 2, 6. That would be 6 again. Yeah, this is nonsense. So let's go with it. 2, 5, 6, 5, 2, 5, 6, 2, 3, 2, 5, 3, 5, 6, 1. I know what this digit is. Of course, it's 1 Sudoku wouldn't break, but let's finish the lines. Yeah. Oh, goodness me. Sleuth, what's going on? Orange is that way. Difference of 3 would be something like that. So I've done 0. I've done 1 almost. Yeah. I've done 2. Kind of. I need to connect it to the 5, but I'm struggling. 3, 4. What I'm left with is I need a difference of 5, which frankly I'm not seeing because I have a 2. No, I've done difference of 5, surely. No, I haven't. I don't have the 1, 6 pairs. I'm going to just plug in this 1 and not get a correct answer. Yeah. "50 minutes. Right. I'm still confident with the fact that it oscillates. And for it to oscillate, I need a difference that is less than 3. And the only way that it's a difference of less than 3 is it's a difference of 2. So I just don't see how I can get away with this. And this can't be 5, and a difference of 2 would make this a 1. Now, Sudoku says this is a 3. These are not 1s. This is a 1. This is a 6. This is a 2, 5 pair. This is a 6. The 1 has to connect to a 3. Like, none of this is controversial. The fact that I used the difference of 2 means that this is a difference of 1. But yeah, I don't have to have a 2 in here, because I was always assuming that these are connecting and therefore the 2 is in the middle. That's a bad assumption. I can have the 2 in here. These are not 3s. And then I could have 1 or 3 in here. Yes, that would be correct. I mean, we know that if I make this a 1 and this a 2, it breaks things down the line. So let's just, for the sake of argument, try this. 2, 1, not 2 is a difference of 1. And therefore these two cannot possibly connect. Yes, so essentially, whether it's 1 or 3, it has to go back to a 2, which is in one of these two cells, basically. And that would make this 5 or 6. Now remember, we did talk about the difference of 5, that I need 1, 6. I need them. So if you look at this, this is not 1 or 6. This is the only one that's 1 or 6. And then I need another cell that is 1 or 6. Admittedly, this is another 1. I could do 1, 6, 1, 6, 1. I could do a very strange loop as such. But regardless, I'm coming back to this cell. 1, 6. That can't be 1. I'm going for it. 6, not 2, 6. That's 3, 5. That's a 1. That's a 2. That's a 3. 1, 6 needs to go back to another 1, 6, remember. That makes this, whatever the blue is, back to here. This is now 5, 6. This is a difference of 2 or 3. We've done the difference of 2. So this is the difference of 3. So keeping track, 0 is done, 1 is done, 2 is done. I'm actually going to change colors for this one. 5 is done. This is clearly going to be the difference of 4. And the only way I can do that is 2, 6, 2, 6. I'm going all out. I mean, why not? And then this one has to be the 1, 6, 1. This is 2. And red would be that one. That 6 gives me 5 and 6. This is a difference of 3, so it would be that one. And this has to go back to 3 again. So that is whatever color it was. Yellow? Not yellow. Come on. And then just fill in the digits. 2, 5. I don't know how people gave this a 2-star difficulty rating, but I'm glad I finished it. And I'm sorry I went over by a good 11 minutes from my own deadline. Sorry, I'm just taking it all in, thinking about how I could have done better. So I think thinking about the fact that every line has a different difference value is like crucial. But the only reason I stumbled onto the solution is essentially I made a bad assumption that led to a problem which got me stuck, which allowed me to go back and clear up the assumption. And it's really, really hard to see how you can make some of these deductions early on, which I guess is kind of almost to me the distinction between 2 stars and higher. So yeah, I'll stick to my guns here. I don't think this is a 2-star difficulty rated puzzle. I am going to post it, and if I get a chance, I'm going to record another one. I'm certainly going to record a much easier puzzle for Sunday night, but what I'm hoping to do is maybe post 2 for tomorrow morning, because this was brutal, at least for me. Looking forward to how you guys got on, just for anybody complains. There you go. Thank you, Marty Sears, for the puzzle. Good luck for you guys. See you back soon. Bye-bye for now.